Hi, I'm Jamie with Chegg Tutors. Today I want to talk to you about an important concept in chemistry that is a limiting or an excess reagent. Those are the two opposite things that something can be in a reaction. So, just very simply, we know this from everyday life. If you have a log at a bonfire that you're burning, you have way enough oxygen to combust, to burn all of that log. The limiting reagent in this case is not the oxygen. You always have enough oxygen unless you're doing it in a bottle. It's the log that you're going to have to add to the fire to keep the reaction going, to keep the fire burning. We've always seen this. Um, if you're making a sandwich and you have 2 jars of peanut butter and 4 pieces of bread, if you're making sandwiches, then the amount of sandwiches you can make is limited not by the amount of peanut butter you have, but by only having 4 slices of bread for 2 sandwiches. The same thing applies to chemical reactions. So in this case, we're taking a log, which is just a form of carbon. We're burning carbon, and you add loads of oxygen to form carbon dioxide and water. This oxygen is the excess reagent. You have too much of it you have too much of it compared to the log. The log is gonna all be used up in this bonfire. The oxygen is not all going to be used up. It would be pretty impressive if we used up all the oxygen in the atmosphere for a bonfire. So the log is the limiting reagent because it's the thing that's going to be used up completely. The oxygen is the excess because once enough oxygen has reacted with the log to burn up the log completely, there's still going to be oxygen left. There's going to be excess oxygen. So this is not a hard vocabulary to remember. The excess reagent is the one that's going to have stuff left over. Now, more typically in these kind of problems, you're looking at a number of grams of each of the reactants. You have to convert that to moles, use the balanced equations like the two here, and figure out which reactant is limiting and which reactant is excess. So it's not going to be as obvious as our sandwich example or our log example. I'm not going to convert things from grams to moles because you probably already know how to do that just by dividing the number of grams by the molecular weight of the compound. I'm going to assume that we have a number of moles. So I'm going to assume here in this reaction, this combustion reaction burning magnesium to form magnesium oxide, that we have 1 mole of magnesium and 1.5 moles of oxygen. Now remember, this is a molecular level process. So a mole of, depending on the balanced equation, here we have that 1 mole of magnesium is going to react with exactly 1 mole of oxygen. There's a 1-to-1 ratio. Anytime we have a balanced equation like this, the coefficients tell you not the relative amount of reactants in mass, but in number of molecules, which we know we have to do in moles. So if I have 1 mole of magnesium and 1.5 mole of oxygen, one way we can do this is to say, well, which if we react the entire thing, is going to form less product. So say I have 1 mole of magnesium. 1 mole of magnesium is going to produce 1 mole of magnesium oxide. If I just say that I have 1 mole of oxygen, 1.5 moles of oxygen, and I don't worry about the magnesium, I can see that I'm going to produce 1.5 moles of magnesium oxide because again, there's that 1-to-1 ratio. So I either can produce 1 mole of magnesium oxide if magnesium is all used up, or 1.5 moles of oxygen is all used up. Now we can tell that there's only going to be 1 mole formed because once we've reacted that 1 mole of oxygen with the 1 mole of magnesium, there's oxygen left, but all the magnesium has been used up. So one way we can identify which is the limiting reagent is to consider each reagent in turn and say how much product is it going to form. Whichever one forms the least product, in this case the magnesium, if the magnesium is the limiting reagent, that is going to be the one that is the limiting reagent. And the other one is going to be the excess reagent. If we want to figure out how much excess we're going to have, we just simply subtract the amount of the number of moles of the excess reagent we have, and we take that and we subtract the number of moles required to react with all of the limiting reagent. So in this case, we'd have half a mole of oxygen gas left because we've used 1 mole of oxygen to react with the magnesium. More typically, you'd want to figure out how many grams or how many liters, in this case, since oxygen is a gas, that you have in excess. But again, you can just do that via standard conversions. Now here, if we react cobalt oxide and oxygen to form cobalt to form this compound, then we have to form cobalt oxide, cobalt 2 oxide. Then we have that there are 4 moles of cobalt for every 1 mole of oxygen. In this case, it's more likely that cobalt is going to be the limiting reagent because we need 4 times as much cobalt in moles as we do oxygen. So often in combustion reactions, oxygen is the excess reagent because we have so much of it in the air. But sometimes in something like this, we need so much more cobalt oxide than we do oxygen that you might find that cobalt is the limiting reagent. And again, you can't tell what the limiting reagent is just from the formula. It depends on how much cobalt oxide here and how much oxygen you have available in your reacting chamber or wherever you're doing the reaction. So you can't tell just from the formula, even if it seems very unbalanced in terms of the ratio of the moles between different reactants. Again, you can do standard conversions to figure out how much excess you have for say, an industrial reaction or whatever reaction you're looking at. You can convert it to grams, to liters, to milliliters of solution, etc. But you want to basically go by the number of moles. Now, why is this useful? Well, if you have an industrial application where you have constraints, probably cobalt oxide is a lot more expensive than oxygen. You want to have enough cobalt oxide so that you can react with all the oxygen, say, but you don't want to have too much. You don't want to have cobalt oxide be the excess reagent because it's very expensive. You may not want to have any left. You may want to use it very efficiently. And that's the kind of thing that we have to worry about when we're thinking about limiting reagent. We also have to think about how not everything is going to, just because you put 2 chemicals together doesn't mean that they're all going to react perfectly. Most of the time they're not, and there's going to be some reactants left. So we really want to use this to reinforce the concept, especially if you're teaching this to students, that just because you put 2 chemicals together that do react doesn't mean that all of it is going to react. Reactions depend on the collisions between molecules, and those collisions need to happen in these ratios that are represented by the balanced formula in order for the reaction to go to completion. That's it for now, and more next time.